Okay, as we work our way through organic chemistry, we're going to need a common language in order to effectively communicate different aspects of structure. So right now, what I want to go over is the most simplest alkanes. We'll start with the alkanes all the way from 1 to 4 here, but you should familiarize yourself with all the names for the alkanes going all the way from 1 up to about 10. That would be really useful in communicating in class. So the simplest alkane structure we could have is CH4. CH4, and the name for this is methane. Okay, so methane, simplest hydrocarbon. Let's go ahead and draw it out. We have a central carbon and we have 4 bonds to hydrogen here. Okay, so we're going to keep adding carbons and hydrogens to make larger and larger structures. So our second hydrocarbon that we'll talk about is C2H6. And this molecule is called ethane. So ethane, we have 2 carbons, carbon-carbon bond, and each of those carbons we're going to fill up with as many hydrogens as we need to reach a total of 4 bonds to each carbon. Right? So our Lewis structure looks something like this. Okay? Let's add yet another carbon, so C3H8, and this corresponds to propane. Here we finally have a large enough structure that we can do a line bond structure instead of a Lewis structure, and so propane, we have 3 carbons, and the only way to arrange those is 3 carbons in a row, looks like that. Okay. Again, this carbon here will have 1, 2, 3 hydrogens on it. This carbon in the middle will have 2, and this carbon on the other side will have 1, 2, 3 hydrogens on it. Okay. Move on to our C4H10 molecule. This is called butane. Okay. So butane, now we have the possibility of 2 constitutional isomers. So we could have a structure where the carbons are fully extended, so we have a linear chain of carbons, or we could draw our C4H10 as a branch structure. So both of these have 4 carbons and 10 hydrogens, but these are 2 different chemicals. They have different names, they have different properties. So the long extended hydrocarbon, whenever it's a long extended hydrocarbon with no branching, we call it a normal alkane. So we call it N-butane in this case. Right? In the case of this branched one, right, the name we give the butane where we have a central branching point and it has a high degree of symmetry, we call that isobutane. Okay? So these are the common simple alkanes going from 1 carbon up to 4. So when we start to go to larger and larger structures, we'll often have side chains or substituents that sort of hang off the side of our molecule. And so we might have 1 carbon that sort of hangs off a longer chain. And we want to give that 1 carbon unit a special name. So here, if we take our methane molecule and we replace one of the hydrogens with another substituent. Let's replace the hydrogen here with a chlorine atom. So when we replace this hydrogen with a chlorine, we end up with a carbon unit here, which is a CH3 unit. And so this CH3 unit, we're going to give that a special name to denote that it's not a whole molecule, but is part of the molecule. So we're going to take our methane name, we're going to keep the meth part, we're going to get rid of the A and E suffix, and we're going to replace it with YL. So this CH3 group is now called a methyl group. Okay? So we can do the same thing with our other simple alkanes. So we go from ethane, we'll replace one of these hydrogens with a chlorine again. So now we have a 2-carbon substituent, or side chain. So here we have C2H5, C2H5. Again, take ethane, get rid of the ANE ending, and add a YL. So a 2-carbon side chain or constituent we're going to call an ethyl group. Okay? We can do the same thing with propane. With propane, things get a little bit more complicated because we have 2 different positions where we can replace a hydrogen. We could replace a hydrogen on the end, or we could replace the hydrogen in the middle. If we replace the hydrogen at the end, so there's our chlorine, we'll draw 3 carbons. We have 1, 2, 3, right? So now, this group here, this is called the N-propyl group, right? So propyl for propane. The N here corresponds to when we have it fully extended in a linear fashion. Okay. If we go ahead and replace the hydrogen at this central position, put a chlorine here, this group here, when it has this geometry, we're going to call an isopropyl group. So again, propyl indicates that it's a 3-carbon chain, and with the iso prefix here, simply means that the substituent comes off in the middle of the propyl group. Okay. Butane, again, things are going to be a little bit more complicated than we had with methyl and ethyl. N-butane and isobutane, we're going to be able to make 2 different substituents from each. So in the case of N-butane, we can replace the hydrogen on the end, 1, 2, 3, 4 carbons. So just like N-propyl, this will be N-butyl, right? If we replace one of the hydrogens in the middle, so 1, 2, 3, 4 carbons, if we replace one of the hydrogens in the middle, this side chain, as we're going to call it, is now going to be called sec-butyl. Okay. Same thing can happen with isobutane. We have 2 different positions where we can put our chlorine atom. We can put our chlorine atom on the central carbon, or we can put our chlorine atom on one of the end groups. It doesn't matter which of our end groups that we put it on. All 3 are chemically equivalent. Okay? So when we do that, we put it on the middle carbon. Okay? And so our new substituent that we've created here, we're now going to call this a tertiary butyl group, or a tert butyl group. And sometimes you'll see this labeled as T-butyl as well, depending on which book you're reading or which website. Okay? We can take isobutane and we can replace one of the hydrogens at the end. And so when we do that, right, our new substituent that we have here is going to have a different name. We're going to call this the isobutyl group. An isobutyl group because it's branched and it has some symmetry about it, right? So these are our simple alkanes, and these are our simple alkanes when they become a substituent. And so what we're going to talk about next is when we move to larger and larger structures, how do we come up with a systematic way of naming these compounds so that we can have a common language of talking about these different structures.